Okay, now we're doing the multiplication counting principle. Right there, the multiplication counting principle. And I'm going to call it the MCP whenever we talk about it, so I don't have to write all this down, right? So we want to know how many ways can I do the very first thing, how many ways can I do the second thing, how many ways can I do the third thing, and then whatever the last step is, how many ways can I do that? Then I multiply all those different numbers together. Multiply, 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 multiply. Okay? So let's look at an example. Here is example number 1. Right? So, if we, I gotta get rid of all my red stuff so we can read that. Yeah. Okay, so here it is. We're going to do a 6-symbol license plate. So what does that mean? Well, it tells you right here that there are 26 possible letters for the 2 first symbols. Whoops, I'm reading the wrong thing. I have to read the question first. Here we go. 6-symbol license plates. So the first 2 symbols are any of the 26 letters in the alphabet, and the last 4 symbols are any of the numbers from 0 to 9. Right? Now you have to remember that there are 26 letters in the alphabet, and then there's 10 possible numbers, because 0 is one of the numbers, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 total values, right? So how do I do it? Well, if my license plate looks like this, the very first letter, how many ways can I do the first letter? Well, there's 26 letters possible. And now they say that we can use any of the numbers, and it doesn't say that we can't repeat, because remember, it's okay to repeat when we do a license plate. So there's 26 letters possible for the first 2 things. So my license plate could start off with AA, or BB, right? Or KM, or WZ. It doesn't matter. So it could be 2 letters the same, could be 2 letters that are different, right? It doesn't make any difference. Exactly. Right? Now, the first digit, there's 10 numbers to choose from, because I could choose 0, or I could choose 1, or I could choose 2, or 4, or 8, right? It doesn't matter. So there's 10 possibilities here, 10 possibilities there, 10 possibilities there. So there's a total of this. You have to multiply all these guys together, and what you get is 6,760,000 license plates that are possible, right? AA 4433. That's a possible license plate. WZ 9992. That's a possible license plate, right? And there's 6 million more, right? That's all the possible license plates that we could get, and you have to multiply them together. Now, here there were no restrictions at all, right? You could use all the things, order was important, and you could use all the letters as many times and all the numbers as many times as you want. But what if we decide that right here, what if we modify the problem? So here I'm going to change the problem. And so instead of being any letter is available, and then or any number is available, what if we said instead that no symbols can be repeated? So now we're saying you cannot repeat the letters. So you cannot have AA, and you cannot repeat the numbers, right? Because it says no symbols anywhere can be repeated. So what do I do then? Well, the multiplication counting principle tells me this right here. Okay, so we get rid of all this business down here. There we go. The first choice, how many possible ways can I choose the first letter? Well, the first letter, there's 26 letters. But then for the second letter, I've already picked one of those letters. It doesn't matter which letter I pick because there's only 25 left. So see, the first number is 26 and the second number is 25. Then when I go down the numbers here, it says the first digit can be any of the 10 values. So it could be 0, or it could be 9, or it could be any number in between. Then after I use one of those numbers, it doesn't matter which number it is. So I could have picked W, and then I could have picked K, and then I could have picked 3, right? But now there's only 9 numbers to choose from, not 10 anymore. So then I pick another number, and now there's only 8 numbers left. And then I pick 1, and then the last number, and then I have this. Now I've got everything. So if I multiply these numbers together, 26 times 25, times 10, times 9, times 8, times 7, there's only 3 million license plates that are possible now. That's whenever no symbol is repeated, right? That's different than the first time. So you're always counting how many choices are there for the first one, how many choices are there for the second one, how many choices for the third, how many choices for the fourth. The idea is you're multiplying all these things together, and then you come up with how many possible things. So we're counting how many license plates we can make. But we're using the rules that say, well, I know if repetition is allowed or if it's not allowed. That's the deal. You know, there's nothing to it other than that. Let's look at another couple of examples before we stop. Okay, so we got to get rid of all this license plate business. Wow. All this license plate business, we don't need that anymore. There we go. All right, let's look at the first one. Okay, can Doreen is this lady, she wants to know, can she wear a different outfit every day of the year if she chooses from 10 pairs of slacks, 12 blouses, and 3 pairs of shoes? Okay, what do I have to know? I have to know how many choices are there for the first one, how many choices are there for the second, and how many choices are there for the third. Well, look, there they are. They tell us what they are. You know, she's not being tricky, right? There's 10 possible pairs of slacks, there's 12 possible blouses, there's 3 possible shoes. If you multiply those together, that tells you how many there are. So 10 times 12 times 3, that would be 360 outfits, right? So does she have an outfit for every day of the year? No way, Jose, because there's 365 days in the year. So if you were answering this question, you'd have to solve this guy. You have to show me what you did. I want to see your work. You'd have to tell me the answer, and then you'd have to answer the question. The answer to the question is, does she have enough to last the year? No, she does not have enough. Boom. Okay. Let's look at a different color here. Let's pick this one. Okay. How many integers from 100 to 999 have at least one digit that's a 0? Oh, this one's tricky. First of all, you have to know how many numbers are there. And so some people think, well, I'll just subtract. I'll subtract 999 minus 100, right? And you say, well, there's 899 numbers. That's not true. There's actually 900 numbers between here and here. There's 900 numbers. So, if you do this idea, if you subtract these two, you have to subtract them and then add 1. Because there's a total of 900 numbers in between here. Now, how many have at least one digit that's a 0? What am I asking? What is it that I want to know? Well, see, my problem here is that, some numbers don't have zeros at all, right? I could have a number that is 1, 2, 3. There's no zeros in that. Or I could have a number 775, right? There's no zeros in that. But I could have a number that was 101. I could have a number that's 305 or 530 or 600, right? All of those numbers have zeros in it. So they want to know how many have zeros. So what I have to do is I have to figure out how many don't have zeros and then subtract that number. There's no way to count it straightforward, so we have to go backwards at it. So how many do not have zero? So here's the deal. Remember that there's 10 numbers to choose from in the very first place, right? There's 10 numbers from 0 to 9. From 0 to 9, there's 10 numbers, right? But we're not using, the very first one cannot use 0 because they tell you the first number has to be 1 or 2 or 3 or 4. So there's only 9 choices for the first one because we're not using 0. And then remember, we're saying we're trying to get rid of all the zeros. So there's 9 numbers to choose from for the second one. And there's 9 numbers to choose from for the third one. You say, wait a minute, why? Why? Because we don't want 0. We're saying, out of these 900 numbers, how many do not use 0? How many do not? Well, 9 times 9 times 9, that's 9 to the third power, that is 729. So we're actually subtracting 729 numbers. These are the numbers right here. These are the numbers that do not have 0. So whenever we answer this question, 900 minus this, that's 171. So there's 171 numbers that actually have at least one 0. So they can have a 0 in the middle, they can have a 0 at the end, or they can have 2 zeros, right? They can never have a 0 in the front because remember the number starts at 100. That's the first number, so you can't have a 0 in it. So the answer to part A is 171. Now, if one of the integers in part A is chosen at random, right? What's the probability that the first and last digit is the same, right? Now, when you do probability, you have to make a fraction. What you want has to be on the top of the fraction, right? That's always the way it works. And then the total number is what's on the bottom of the fraction. The total number. So when I make a probability, I always make a fraction. So if I pick one of the integers in part A, so that's 171, that's the total number of numbers I can pick from. All the numbers that have zeros in it. So I'm picking from 600 or 530 or 305 or 101, right? What's the probability that the first and the last digit is the same, right? So what am I picking from now? I'm saying numbers like this: 101, 202, 303, 404, right? How many numbers are there like that? Well, you can count them. 101, 202, 303, 404, 505, 606, 707, all the way to 909. There's 9 possible numbers. So what's the probability that the first and last digit's the same? 9 out of 171. Now the cool thing about your calculator is you can reduce that fraction. 9 divided by 171. Can we see that? There we go. Nope, we still can't see that. Where's a good place? Right there. 9 divided by 171. So I'm going to hit the math button. And then I'm going to hit the enter button because that tells me I want to make it into a fraction. Look at that. 1 chance out of 19. 1 out of 19. And if I wanted to make that a decimal, I could just say, what is 1 divided by 19? And it would tell me 5% of the numbers, or 0.53, right? 5.3% of the numbers are that way. So if I said, what's the probability? Probability is always a fraction. You could answer with 1 over 19, right? That's a possible answer. You never answer with a fraction you can reduce. If you can reduce the fraction, you have to reduce the fraction. So 1 over 19 is the answer, or 0.053. 3 decimals is all you need, right? If you want to make that a percent, you can. 5.3% of the numbers would have the first and last digits the same. Ta-da! How about that? Okay, let's look at, let's see if we can do a couple more, and then we might be done. Yeah. Maybe we can get this up here where we can read number 4, and then we can, there we go. Oh yeah, number 4. There we go. How many 5-letter code words can be made from the letters C, E, G, M, R, S, U, and W? So that's 1, 2, 3, 4, 5, 6, 7, 8 letters, right? So, if the letters can be repeated, what would I have to do? Well, think about it. If the letters can be repeated, I have to figure out how many there are. So 1, 2, 3, 4, 5, 6, 7, 8. So I would have 8 times 8 times 8 times 8 times 8. Oh my goodness! Times 8 times 8 times 8. Right? What is that? That's 8 to the 5-letter words. 5-letter words. I was doing 8-letter words. That doesn't work. How many 5-letter words? 1, 2, 3, 4, 5. There we go. So what's the answer to this problem? Well, the answer is 8 to the 5th power, right? 8 to the 5th power, which is a gigantic number, 32,768, right? What if the letters cannot be repeated? Well, that would be different then, wouldn't it? It would have to be, let's say, you still start with 8, right? But after you use a letter, after you pick one of these letters up here, then there's only 7 letters to choose from. And then there's 6 letters to choose from. And then there's 5 letters to choose from. And then there's 4 letters to choose from, right? Well, that's different. That is 6,720. 6,720. This one was 32,000 768. 768. 32,760. That's lots less, right? What if the first letter has to be an E? Well, then there's only one choice for the first letter, right? And the last letter must be an S. Well, there's only one choice for the last letter, right? And then, so the first letter is an E and the last letter is an S, so those are gone. And then there said there's no repetition. So what's left? 1, 2, 3, 4, 5, 6. There's 6 letters left. So there's going to be 6 choices for this one, 5 choices for this one, and 4 choices for this one. So that, if you multiply those numbers together, it's only 120. Oh my goodness! Right? That's lots less than 32,000, right? But we're restricting it. We're saying the first letter has to be E, so E can't be anywhere else. The last letter has to be S, and S can't be anywhere else. And there's no repetition. So there's only 120 words that start with E and end with S and use all these letters. Right? That's the deal. Okay, the next example is license plates. We've already done license plates. That's enough for now. Bye.